This video is on solubility rules. So some words that we need to know with solubility rules. Soluble is any substance that dissolves or dissociates into ions. Insoluble is a substance that does not dissolve or dissociate into ions. Aqueous is the state of matter when a substance has dissolved or dissociated. So something that is soluble becomes aqueous. And the solid is what we'll give to a substance that is insoluble. So when we write a chemical reaction, we need to determine states of matter. Aqueous we show as AQ, and a solid we show as an S. Now something can dissolve or can dissociate into ions. Things that dissociate into ions are ionic solutions. And things that dissolve can be covalent items, can dissolve as well. So we have a chart of solubility of some ionic compounds in water. Now this chart would be different for covalent compounds. This chart would be different if it was not in water. But we're just going to stick to ionic compounds in water. Now to read that, we have to focus on our anions. Remember, the anion is the second half. So in an ionic compound, we have a metal with a nonmetal, and the nonmetal's part is a negative charge, and the metal has a positive charge. We have a cation and an anion. The second half is the anion. That's the part that we're looking at. So the second half of our compound. That second half of the compound, we find that on our chart. And then we look at the first half of the compound, the cation, and that tells us if it's soluble or not soluble. If we look a little closer at this, in our cation side, we have words like except. So if we look a little closer, any negative ion paired with any alkali metal, group 1, is soluble. So that means that it's aqueous. Any negative ion paired with ammonium, NH4, is soluble, aqueous. A nitrate ion plus any positive ion is soluble, and so on. When we get to chlorides, bromides, or iodides paired with any positive ion except silver, lead, mercury, or copper are soluble. So that means that if I have silver chloride, it's insoluble. So let's look here. I'm just going to underline my except here. This one's good. Notice here at the bottom, it says all positive ions are not soluble. So other ones, whereas the top half are soluble. Same thing with hydroxide. This one's broken in half. And with phosphate, carbonate, or sulfite. This one as well has two options. So just some things to note about our chart. Let's do two examples. Calcium chloride. My anion is chloride, so it's a CaCl2. So I find chloride. My chloride is here. Chloride plus any positive ion except silver, lead, mercury, or copper. Well, I have calcium. So it's not one of my exceptions. So that means this is soluble. So when I'd write this in a chemical reaction, CaCl2, and then I'd write AQ after it for it being aqueous or soluble. Magnesium sulfide, I look up my anion, which is sulfide. Sulfide is here. Sulfides plus alkali ions, that's group 1, ammonium, alkaline earth ions, which is group 2, are soluble. Well, magnesium is in group 2, so it's soluble. So MgS is soluble, so I'd write AQ. So what does this look like in solution? Well, if I have a beaker and my beaker has water in it. Remember, these are compounds in water. And I take that and I add into it calcium chloride and magnesium sulfide into my beaker. Originally, I'll have calcium chloride and magnesium sulfate sit on the bottom. If I then stir this up, I'm going to dissociate my calcium chloride and magnesium sulfide because they're aqueous. So that means that they don't just sit in the bottom of my beaker of water. They break apart into their ions. So that means in my water, I have chloride ions and calcium ions and sulfide ions and magnesium ions all floating around, no longer bound together. And that's what that means if it's soluble or aqueous. So aqueous really means broken down into its ions floating around in my solution.